Hey guys, it's Mr. Verdi here. Quick little discussion on the immune system. It's going to be a very, well, I can never guarantee brief, but it's going to be an overview of the immune system, okay? We're going to look at the immune system and notice that it's divided into two major divisions, an innate division and then this acquired division, often called the adaptive. I like this term better. Okay, and you'll see, when we think innate, it's usually we think of something that we're born with, okay? So we're born with our innate immune system. Our adaptive immune system, our acquired immune system comes with exposure, okay? And we'll show you what we mean. All right, so first off, with the innate immune system, you can think your skin and mucous membranes as part of your innate immune system. Keep the invaders out. Once something gets into your body, right, if it breaks through that skin and those mucous membranes, there's another layer of the innate immune system that features a whole bunch of cells, eosinophils, basophils, macrophages. There's cells called natural killer cells. The immune system is pretty cool and well marketed, okay, by the naming of some of those cells. All right. Now, a big difference between innate and the acquired immune system. Let's think about it as, what's the opposite of innate? Learned, acquired, extrinsic, right? Let's think about a rolled ankle for the innate immune system, okay? If you roll your ankle, all right, today, well, what's going to happen? It's going to swell, it's going to turn red, it's going to be painful, right? And you'll heal in about 2 weeks, maybe, okay? Depends how much treatment Heather can get to you, all right? Now, if you roll your ankle again 6 weeks later, the recovery time isn't going to be quicker, right? You're not going to be better necessarily at handling the same type of stress because the inflammation response is considered part of that innate division. Okay, so when you roll your ankle, all right, it's tissue damage. You don't really adapt to it, I guess, in your response to that tissue damage. All right, that's the innate immune system. The biggest difference between these two is the adaptive immune system remembers an injury or an invader that it met, and it adapts in its response to that deal. Okay, so let's go and look at some cool things about the adaptive immune system. The adaptive immune system is broken down into T cells and B cells. All right, and what you've got are hundreds of thousands of what I call naive, not me, okay, these are not my words, these are just what I've learned, okay, from countless sources. Okay, B cells and T cells are naive, and you've got hundreds and thousands of different types of them. Okay, so this is a little cartoon I found, a simple image search, okay, for clonal selection. Here's what we're looking at. You're looking at, in this case, I chose B cells. Looking at B cells, so you might have one B cell with little ant. These are receptors that are going to bind to a pathogen. Okay, as we look here, receptor for pathogen. A different B cell, the one right next door, very similar, except it's got a slightly different receptor that would recognize a different pathogen. Okay, again, a pathogen, or really I should say antigen, right? But a pathogen is something that can make you sick. Okay, similar looking receptor, but notice there's a slightly different slant. Different receptor for a different antigen, different receptor, different receptor, different receptor. The point is, you've got hundreds of thousands of these naive B cells and T cells that are hanging out at very low levels. All right, really just kind of chilling, not doing much until they undergo clonal selection. What that means is a particular pathogen, perhaps, or invader, has the matching antigen that matches to this receptor. So an antigen belonging to some foreign particle, right? What happens is once this particle has this antigen that matches with a naive B cell, this particular B cell undergoes clonal expansion. Okay, whoa, that sounds like a movie, right? Clonal expansion. It's going to undergo mitosis hundreds of thousands of times. This and only this B cell. This response is very specific, okay? Whereas like you have the inflammation response to a baseball in the head, okay, or a rolled ankle, it's the same inflammation response. You're going to have a very different B cell for strep versus the flu. Okay, so here we go. Clonal expansion. This is going to expand in numbers by hundreds of thousands. All right, and now this could be in B cells or T cells of clonal expansion. In this case, looking at B cells. All right, it's not a bad chance to look at the difference between B cells and T cells now. Okay, so once your B cell has been selected for, these cells are going to differentiate. And you're going to notice B cells differentiate into antibody secreting cells. We call those plasma cells. They secrete these antibodies, these little things right here. Antibodies are proteins, by the way. They secrete those antibodies into your plasma, right? Or your body's liquid, right? And a fancy name for liquid is called humor. You're going to see I wrote a little essay. Your humoral response is composed of your B cells. Okay, T cells, let me see if I put a little picture. Oh, here's just another little picture of, T cells and B cells working together. This is for another day. This is a deeper layer that we're going to uncover. Okay, but I didn't put anything on here about T cells necessarily. Here you go. So, sorry kids, I just made this, I swear. So T cells and B cells, T cells have the ability to kill invaders that have taken over your cells. Okay, wait, what do you mean? So a B cell secretes these antibodies in your body's liquids, right? The humoral response. These antibodies will be everywhere. We're talking one cell secreting 500,000 antibodies, maybe an hour, and then hundreds of thousands of these cells. You're going to make a lot of antibodies when you get sick, okay? Try one test. What's the test we're talking about doing for the coronavirus? An antibody test. What are they looking for? An antibody that your body's produced for the coronavirus. Okay, if you have that, it means you were probably exposed to the coronavirus and your body's ramped up production of these antibodies for it. All right? The goal of the B cells is catch that coronavirus before it invades one of your cells. Well, what happens if it invades one of your cells? We've got another line of the adaptive immune system for that. That's the T cells. Okay, now CD8 positive and CD4 positive. The immune system is fascinating. For just an overview, I want you to think that cytotoxic T cells can kill cells that have become infected. So imagine that coronavirus gets into one of your cells. The antibodies are defenseless against that cell now. Well, what do we need? We need cells that are specialized at finding cells that have become little viral factories and killing it. And that's where these cytotoxic T cells come in. Okay? So cytotoxic T cells, they'll find cancer cells, right? If a cell's gone wrong, the cytotoxic T cell is going to be the key. Helper T cells, these CD4 positive cells, and sometimes there's also suppressor T cells out there. They can talk to B cells, cytotoxic T cells. Helper T cells can talk to all kinds of different cells, all right, to kind of activate or dampen or modulate the immune response. Okay. The last thing I want to talk about is you've seen something about vaccinating for the coronavirus, and you've seen something that, well, maybe people will have it, they can rest assured they won't get it another time. Well, how can that be? Well, both B and T cells produce memory cells after clonal expansion. Meaning, so if we follow this, the concentration, so this is for B cells, right? That naive B cells barely, is at some super low level if it's naive, if it's never met its pathogen before. But once you get sick and that B cell's undergone clonal expansion, it's going to ramp up, obviously, antibody production. Cool? Well, once you defeat that bacteria or virus or pathogen, we're going to get rid of most of those B cells. We don't need them, and it's a waste of energy. It actually takes a lot of energy. Usually when you're sick, you don't feel like doing as much as you used to because you're spending so much energy fighting that virus or bacteria. So what happens? We drop in numbers, but not completely. Notice this will not go back down to zero here, but it depends on time, right? But what happens when you have memory B cells and memory T cells? Okay, and we keep those at higher levels if we compare right here to right here for a long time. It depends on each pathogen, but those memory B cells can last sometimes your entire life. Now what happens when you go and meet that virus a second time? Well, first off, we're going to get a much greater magnitude of response. See this secondary immune response? Okay, much greater than this primary immune response as far as concentration of antibody produced. Second off, maybe not as obvious to you when you look at this, is the lag time. Look at from here, and there's no units involved, but just if we could measure from this point to this max point on the x-axis, the time it takes to have this response is much shorter. And this is why it's called the adaptive immune system. It adapts to things that it encountered earlier in your life. This is how vaccines work. Vaccines provide some initial exposure of an attenuated strain of a virus, okay? And they just kind of introduce your immune system to it so that you ramp up the guards for it. Now, if you meet it, the immune response hopefully is extreme enough and fast enough you don't even get sick with it because you've got a strong enough immune response, okay? So that's our big difference in the adaptive immune response compared to the innate immune response. The adaptive immune response is super specific, right? You're going to have one type of response for chickenpox and a whole nother type for strep throat, all right? Also, there's a memory involved. Remember we said if you roll your ankle, my rolled ankle, 3 weeks ago when I fell in the parking lot, shoot, that was 3 months ago, right? Compared to when I rolled in 8th grade playing basketball, exact same, okay? We don't heighten our innate response, but our adaptive immune response, that, my friends, can adapt, okay? That's it, guys. Thanks for stopping by. Have a great one. Bye.